Last stage, we watched a language model predict the next token, and we just trusted that a forward pass happened inside. Now we open the box. By the end of this episode, you will be able to follow a single piece of text from raw characters all the way to a next word guess. Every box it passes through in order with nothing skipped. Start with the whole journey on one screen. Text goes into a tokenizer and comes out as integers. Those integers look up vectors in a big table. The vectors ride up through a stack of identical blocks. At the top, one more layer turns them back into a score for every possible next token. That's it. Everything else is detail inside the stack. Here's the idea that makes the whole thing click: the residual stream. Picture the vector as a running draft that travels straight up the middle. Every block reads the draft, writes a small correction, and adds it back. Nobody erases and restarts. That's why the shape, batch, sequence length, hidden size is exactly the same coming out of block 32 as going into block 1. Zoom into one block, it has two crews. First crew, normalize the vector, run attention, add the result back. Second crew, normalize again, run a little neural network we call the MLP, add that back. Two sublayers, two residual adds. Stack that 32 times and you have the body of the model. One split to remember because it explains the entire back half of this course. The MLP holds about 2/3 of the model's parameters. That's where the bulk of the knowledge lives. But attention is the part that gets expensive when you actually run the model because it compares every token to every other token and it remembers the past in a cache. Parameters live in the MLP. The running cost lives in attention. Hold on to that. Let's walk the whole pass beat by beat with the real model's numbers on screen. Llama 3.8b. Start at the bottom. The sentence NVIDIA makes GPUs going into the tokenizer. Tokenizer turns it into integer IDs, a tensor of shape, batch by sequence length. Those IDs index into the embedding table, one row per token, and out come vectors of width 4096. Now the stream exists, batch, sequence, hidden. Light up the stack, 32 identical decoder blocks. Watch the shape label on the side of the stream, 4096 in, 4096 out, every single block. The vector is the same width the whole way up, only its contents change. Pop one block open, norm, attention add, norm, MLP, add. Notice the two side rails, the residual skip lines that carry the original vector around each sublayer so the correction gets added, not replacing the draft. At the top, one final norm, then the LM head, a layer that maps the 4000 wide vector to a score for all 128,000 tokens in the vocabulary. Softmax turns those scores into probabilities. The highest one is the model's next token guess. One pass, done. Next episode we go back to the very first step we glossed over, how a token actually becomes a vector, and how the model knows what order the words came in. The answer is a clever trick called rope. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.